So the particle is moving in straight line and displacement is given by this equation, x is equal to t minus 2 over t plus 2. So it says when is the displacement, what is the displacement at t is equal to 0. So when we just plug in t is equal to 0 there and we get minus 2, 2. So that's the displacement at t is equal to 0. Now we have to show that for the second one, let's just rewrite this one. So t plus 2 minus 4 we can write in the numerator, t plus 2, because 2 minus 4 is minus 2, so I have just rewritten. So this is becoming like that, minus 4 t plus 2. So this is 1 minus 4 t plus 2. So this one is shown, it's proved. And from here we have to find the expression for velocity. As we know, velocity is the differentiation of displacement with time. So if we differentiate this one is negative 4, then negative 1 t plus 2 square. The reason is t plus 2, it was negative 1, so it's becoming negative 1, t plus 2, negative 2, so that negative 1, so it's becoming 4 over t plus 2 square. This is the expression for velocity. And if we want to find the expression for displacement, that's the differentiation of velocity with time. So this is again becoming 4, then negative 2, t plus 2 half 3. So it's becoming, I will rewrite here somewhere there. Will need to erase everything to get my space. A is becoming minus 8 over t plus 2 cube. So the question is the particle ever at rest? So I will just go back to erase this thing, and v is equal to 4 t plus 2. So whenever it says that is the particle ever at rest, that means when the velocity becomes 0. So we can look at this expression and we can say that the velocity will never become 0 because t is always a positive value, and this one is a t plus 2, so t cannot be negative, and t plus 2 then also a positive value, and this expression will be a positive value since this is also a square. So v will never be 0, so particle will never be at rest. And what is the limiting velocity of the particle as t increases? So to find limiting velocity, we have to see what is the velocity when t tends to infinity. That's the limiting velocity. So when t tends to infinity, v becomes this denominator, which is the expression here, this one becomes infinity, and when this one becomes infinity, then the velocity does become 0. So yes, the particle is at rest and the limiting velocity becomes 0. We can say that. As when t is infinity, this v is 4, the denominator is infinity, so of course something over infinity we will get 0. So this happens, the limiting velocity when t tends to 0, limiting velocity is 0. Also when t is equal to 0 here, we can see that velocity is 1 because 4 over 4, so velocity will be 1, and t will be either 0 or a positive value. When it's positive, this one is, as we saw, that the velocity is never becoming 0 when t is a finite value. Only it's becoming 0 when t is approaching infinity, and at t is equal to 0, velocity is 1.